Hello, everyone. Welcome to the third conference on signal processing and machine learning. My name is Dr. Mukhtar Ullah, professor at FAST School of Engineering, National University of Computer and Emerging Sciences, Islamabad. I'll be delivering my keynote on machine learning, which is automated optimization and disguise. So here is the outline. I take you through a roller coaster of existing capabilities of artificial intelligence and machine learning, the machine learning landscape, the machine learning tools, and a case study in health sciences. And obviously, I'll conclude the talk by the take home. I'll begin my talk with a very famous quote from the German philosopher Immanuel Kant, that perception without conception is empty, and conception without perception is blind. So the way I explain this to my students is that we should appreciate the importance of experiments, like the perception, as well as the theory, the conception. So we are living in a data-driven world, and only when the data, the perception, is combined with the theory, the conception, can we make informed decisions about important matters. So what are the things, what are the different capabilities? What are the things we can do with the existing AI and machine learning tools? So if you look around, AI and machine learning plays a key role in protecting our lives as well as the environment. In the transportation industry, different casualties can be avoided by AI-assisted driving, autonomous cars, unmanned air vehicles. Of course, these unmanned air vehicles are typically associated with warfare, but they have been used in vast numbers for peaceful purposes, for package delivery and other applications, and surveillance and sports coverage. When it comes to online security and safety, AI and ML can be used to filter violent and hateful content and misinformation spread by different agencies for different purposes. And we can monitor the environment. When it comes to healthcare, as you can see on the right, medical images can be analyzed using machine learning. AI-assisted diagnosis. The reliability of diagnosis can be improved when you combine machine learning technology with the human doctors, with the expertise of the human doctors. And you can design new drugs, new therapies, and other procedures, and you can improve patient care, like a controlled drug delivery, for example, and to control insulin, for example. As one example. When it comes to online interaction and content moderation, the tools such as Metaverse, which was previously Facebook, Google, YouTube, Amazon, Azure, they would not have been possible without AI and ML, because they rely, the key component in all these tools is machine learning. With AI and ML, we can deal with the vast amounts of information generated every day, every minute, I would say. You can rank different pages, search and retrieve, and response to queries by user, question answer. Machines can be trained to understand the context. And chatbots, like the recently launched ChatGPT by OpenAI, uses the large language model with reinforced learning to come up with a tool that has taken the internet by storm. When it comes to translation services and related services, these tools can be used to uh, translate one language from another to another, text to speech, speech to text, image to text, text to image, and objectionable content such as hate speech, violence, uh, suicide, self-injury, typical in these days among teenagers, bullying and harassment, child endangerment, pornography, nudity, yeah, spam, fake accounts, terrorism. All these undesired activities can be filtered out by content moderators. Um, Automatic image understanding plays a key role not only in health but also in businesses like online shopping. Yeah. So if you look at this image, the different parts can be segmented by an automated algorithm using machine learning. Sometimes, so like especially in the medical applications, the raw images are not suitable for identifying different parts for image segmentation, and contrast improvement can be done by machine learning tools. We will see an application in the case study. Uh, it is also desirable to avoid direct image capture because image capture generates lots and lots of data, so which is not only uh, a footprint on memory but also on processing. It's time consuming. So one wonders, what if we could um, go directly from raw data to diagnosis and screening and avoid the image processing. So as you can see on the right side, um, these such 2D image uh, can be generated directly for human readability. So AI and ML systems, they can take scarce, low resolution raw data, inexpensive of course, undersampled, instead of large volumes of data. So such deep learning systems can be trained to directly produce a screening result. Yeah? So artificial image generation is will be seen more and more in days to come. And, and progress in biomedical sciences is driven by AI these days. So in neuroscience, for example, brain models have been developed, and models for vision, auditory, and speech, they have been developed, both from low level to high level, as you can see on the right side. In genomics, proteomics, and metabolomics, entire gene regulatory networks can be identified using machine learning technology. Um, protein interaction networks, important for disease identification and study, disease models, and genetic diseases can be managed, and viral loads can be managed, viral loads such as HIV. So when you cannot eliminate a virus, I mean, the least you can do is to manage the load. In biosciences, new functions and structure of proteins can be predicted by machine learning. And you can design new protein sequences. You can identify potential targets for drugs, and you can discover new drugs, therapies, and other procedures, other intervention procedures. Progress in physical sciences is also driven by AI these days. Instead of using conventional um, tools, mathematical tools, AI is being used to analyze large sets of data generated at the Large Hadron Collider, which is abbreviated as LHC. Complex simulations the molecular simulations, detailed molecular simulations, are so accurate these days that they can replace expensive experiments. Uh, and it also includes progress in astrophysics. In chemistry, you can discover new compounds because the different models in chemistry uh, can be used to predict new compounds. And when it comes to material science, says uh, new material properties can be predicted, and new metamaterials can also be the structure can be predicted, and then the engineers can work on building those materials in lab. And applications in geoscience include combination of geophysics with AI tools, and then you can analyze the spatial data for mapping purposes. So all these Google Map services provided by Google Map, they combine GIS with AI. So to hear more about this ChatGPT thing, you can view this as an AI-powered assistant. Um, the project was started by OpenAI last year, and it came in the form of InstructGPT, and further improvements uh, were made. And by the end of 2022, the ChatGPT was launched. So uh, it combines the large language model with reinforcement learning, and it has taken the internet by storm these days because people are testing it. I have also tested it myself, and the answers that it is providing uh, are quite amazing, because you wouldn't expect a chatbot to write an essay, for example, a sophisticated essay, and you can give it mathematics problems, physics problems. You can ask it to write code in whichever language you ask, and it will not only provide the code but also comment, and then it will give you test cases. Of course, nothing is perfect, but it's a huge improvement. The machine learning landscape now. So the most common form of machine learning is called supervised learning, in which you need a supervisor, such as a human or any other intelligent uh, agent, to train the computer. And it comes in two forms. Um, if the predicted quantity is continuous, such as a real number, then you call it regression. And if you predict just labels or discrete quantities, then you call it classification. But what is common in both, and that the reason why it's called supervised learning, is that you need to give it examples. So the true value in each example is known of the output, and only when the agent is exposed to those examples, it can then be trained. So here is one example where different pages can be ranked um, to such as 1, 2, 3, and the ranking can be based on some desired property. Unsupervised learning doesn't require a supervisor, so which means that no true output is told, but the data can be analyzed to find similarities, uh, and automatically turn the data into meaningful clusters. And this can be used. This can also be used for outlier detection, as you can see on the image on the right. Unsupervised learning can also be used for what we call the independent component analysis. So, like in a multi-speaker room, different receivers can focus on different types of speakers, and all this is done without any supervisor. The two approaches can also be combined in what we call the semi-supervised learning, and you can then use the results of unsupervised learning, like the clusters, to facilitate the training of the supervised learning. Um, Another form, which is inspired by feedback control systems, is what is called the reinforcement learning. And this, the computational agent interacts with the environment, and the different actions and observations are used to come up with a policy which gives rewards for desirable actions, and it gives penalties for undesirable actions. The different machine learning tools existing today. Um, you see in this diagram all the different uh, types can be seen to stem from just a few. So they are either different types of supervised learning or of unsupervised learning. Then reinforcement learning has its own category, and then these basic types can be combined into ensemble learning and deep learning. So this diagram, I have also provided a link, um, can be used specifically by students to have an overview of all the different types of machine learning available. So they're connected in a very natural way. The different machine learning paradigms, two main paradigms. One is the classical, traditional machine learning, also called conventional machine learning. Here you need a human level expert to design useful features. That's why it's called feature engineering. And only when you take the raw data into a feature space with features as coordinates can you train a classifier. So this has been how machine learning um, was practiced for a long time. But recently, um, a new way of looking at this problem is called deep learning. And this uses a hierarchical strategy to automatically extract features. So you don't need a human expert to identify features. That's why they're also called autoencoders. So as you can see in the figure, in the bottom figure, from raw data, you first identify low-level features, and then mid-level features, and then high-level features. And this is done by different layers. That's why it's called deep learning. So you go deep into different layers, and you eliminate the human expert. In both cases, a quantity called the empirical risk or cost function is preferred by economists, that is minimized. That's why I said in the beginning that machine learning is nothing but optimization done in an automated way. The case study I would present is comes under representation learning, and this was a recently published paper, a multi-layered basis pursuit algorithm for classification of MR images of knee ACL tear. Um, so the main idea is to use sparse representation to avoid dealing with massive data. So the algorithm is called iterative shrinkage thresholding algorithm. And when you exploit sparsity, um, you can then provide the results to other stages of machine learning, deep learning to be precise, such as convolution and pooling. And the results can be a huge improvement. So here, this approach has been validated on real data. And as you can see, all the evaluation metrics such as precision, recall, accuracy, and F1 score, uh, different unfoldings, our approach shows a significant improvement when compared to other existing approaches. You can also see it in the confusion metrics, and you see the machine learning star with unfoldings 1 and with unfolding 2 is shown on the left hand side. Um, and the different metrics can be seen here. So if I summarize my talk, I took you through the different capabilities of AI and machine learning. Then I gave you an overview of uh, um, machine learning landscape, machine learning tools, and a case study. And I would close this talk by one conclusion that machine learning is the leading technology in transforming our civilization, and we will see its fruits in years to come. Thank you.